So what if I told you that the reason a basement in Florida is flooding today is actually directly linked to a pine tree catching fire in Oregon, like 3 days ago?
I mean, it sounds crazy, but it's entirely true.
Right. Most of us just pull up a weather app, look at the little icon over our zip code, a sun or a rain cloud, and we just assume that's the whole story.
Hmm.
We treat weather like it happens in this complete vacuum.
Which is honestly an incredibly dangerous illusion. When you zoom out and look at the continent as a whole, those neat little geographic boxes we draw, they just completely disintegrate.
Yeah.
Because our atmosphere is a closed-loop physical system. Energy doesn't just vanish when it crosses a state line, it transfers. Every ounce of heat, moisture, and pressure is locked in this massive, high-stakes game of physics, just constantly pushing and pulling against each other.
Yeah, absolutely. And, well, welcome to today's deep dive where we are going to expose exactly how that massive atmospheric engine actually works for you.
Yeah, it's quite the engine.
It really is. So we're pulling from this highly detailed August 1st, 2026 Daily Tech Reader report. It covers extreme weather across the entire United States. And our mission today isn't just to, read you the forecast.
No, definitely not.
We're going to decode the underlying mechanics of this whole system.
Yeah.
We want to trace the movement of thermal energy from this staggering inferno in the Pacific Northwest, watch it mutate across the Great Plains, and understand how it ultimately triggers catastrophic flooding all the way on the East Coast.
And to really grasp the sheer scale of the energy we are talking about here, we have to look at this through the lens of an energy transfer equation.
Okay, an equation.
Right, because the atmosphere is desperately trying to reach an equilibrium that, frankly, it will never actually achieve. So when we see unprecedented heat in one corner of the map, it is an absolute certainty that we will see violent atmospheric reactions thousands of miles away as that heat tries to disperse.
Wow. So let's track that initial surge of energy, starting at the extreme upper left of the match, up in the Pacific Northwest. Because the sheer volume of thermal energy being released in Oregon right now is just staggering. I mean, the state is nearing its all-time wildfire record. We're talking about 1.7 million acres burned.
Yeah, which is closing in fast on that devastating 2024 record of 1.93 million.
Exactly. And the physical reality of 1.7 million acres burning, I mean, it's just difficult to even comprehend.
It really is. To put it in perspective, the Big Grass Fire in Malheur County alone has consumed over 303,000 acres.
Wow.
And it is currently crossing over into Idaho, and get this, it's only 21% contained.
That is just wild.
And what's fascinating here is how the atmosphere is actively engineering an environment that makes these fires almost impossible to fight.
Because of the weather conditions.
Exactly. The National Weather Service has blanketed the entire region in red flag warnings.
Right. And okay, let's unpack this for a second, because we see that term red flag warning flash on the news constantly during the summer. But what is the actual physical threshold that triggers it?
Well, a red flag warning isn't just a generic alert for a hot day. It is a highly specific mathematical formula that tells fire agencies the atmosphere has literally become a weapon.
A weapon. Okay.
So, it usually requires 3 overlapping conditions. You need temperatures soaring past 90 degrees Fahrenheit, wind gusts sustained over 30 miles per hour, and relative humidity plunging into the single digits.
Wait, single-digit humidity? That means there is virtually no water vapor in the air whatsoever.
None. 0. And the physics of that are actually terrifying.
How so?
When the air is that dry, it actively seeks out moisture from anywhere it can find it, which, if you're in a forest, is the vegetation. The atmosphere literally sucks the water right out of the trees, the brush, the soil, and it turns the entire landscape into flash paper.
Oh, wow.
Yeah, so when you combine that brittle, completely desiccated fuel with 30-mile-per-hour winds, a single spark doesn't just catch. It gets carried for miles.
Right, like jumping ahead.
Exactly, igniting these spot fires far ahead of the main blaze.
Which creates a total mathematical nightmare for the people trying to contain it.
Oh, absolutely.
I mean, the source material notes that Oregon is currently at a national preparedness level 5 of 5. That basically means the entire system is tapped out.
Yeah, totally tapped out. Every available bulldozer, helicopter, and hotshot crew is committed.
And, looking strictly at the logistics and the math of disaster management here, the sources note that the Trump administration recently denied federal firefighting assistance grants for 2 of these significant Oregon fires.
Right, although they did approve others that were requested by Governor Tina Kotek.
Yeah, exactly. We're just looking at the facts in the report here. But it really highlights the strain on resources.
Absolutely, because when you are operating at preparedness level 5, Your margin for error is zero. Regardless of the political mechanics behind those grant approvals or denials, the physical reality on the ground is that local and state agencies are forced to manage historically massive infernos without the specific financial and resource backstop those grants provide for those particular incidents.
It's just brutal.
It really highlights that severe friction between finite human resources and just infinite atmospheric energy.
Right. And all that burning organic matter, it's releasing an unfathomable amount of particulate pollution. Like the intense heat of 1.7 million acres burning actually creates its own weather.
It does. It pushes these massive plumes of smoke so high up into the stratosphere that they literally get caught in the jet stream.
The jet stream, which is basically a transcontinental conveyor belt, right?
Exactly. It's a fast-flowing river of air miles above the surface. So the smoke from Malheur County gets sucked up into that river and transported all across the country.
Which is why the report details hazardous air quality stretching across the Great Plains and reaching all the way down into Florida.
Yeah. A tree burns in Oregon, and 3 days later, someone in Miami is breathing it in.
That is just incredible. But, the intense conditions fueling those fires in the Pacific Northwest are just one symptom of a much larger atmospheric structure.
That's right.
Because that smoke is riding over the top of this suffocating heat dome that is essentially just cooking the western half of the North American continent.
Yeah, and that heat dome is the core engine of everything happening on this map right now.
How does that actually form?
Well, a heat dome occurs when a sprawling high-pressure system just parks itself over a region.
Right.
In a high-pressure system, the air is physically sinking. We call that process subsidence.
Subsidence.
Right. And as that massive column of air sinks, it compresses. Basic thermodynamics dictates that when a gas compresses, it heats up.
Oh, right.
So this dome basically acts like an invisible atmospheric anvil. It traps heat at the surface and continually bakes it day after day.
And the temperatures recorded under this anvil are just lethal. I mean, this is the peak of a historic heat wave across the desert Southwest.
It's brutal.
Phoenix and Las Vegas are approaching 115 to 120 degrees Fahrenheit. Death Valley is nearing 125 degrees. And Maricopa County alone has confirmed 40 heat-related deaths so far in 2026.
It's a tragedy. And what makes this so deadly isn't just the afternoon peak, it's the overnight lows.
Really? Why the overnight lows?
That is the most insidious part of a heat dome. The sources note that overnight temperatures in these cities are only dropping into the low 90s.
Wow, that's barely cooling off at all.
Exactly. And when you build massive urban environments out of concrete and asphalt, they act as thermal batteries. They absorb that 115-degree heat all day and then radiate it back out all night long.
So it never really stops.
Right. If the ambient air never drops below 90, the concrete never cools. And more importantly, the human body never gets a chance to shed its thermal load.
Oh, I see.
The physical stress just accumulates until internal organs actually begin to fail.
That is a profound public health crisis.
No.
And this dome is expansive, too. Up in the Mountain West, places like Boise, Denver, and Salt Lake City are consistently topping 100 degrees.
Yeah. Billings, Rapid City, and Sheridan hit all-time records in July, too. Red flag warnings are up across Montana, Idaho, Wyoming.
And over in California, the Central Valley is baking between 100 and 110 degrees. The report notes that NOAA's strongest above-normal temperature signal is parked right over California.
It's relentless.
And to make matters even more chaotic, while the interior of the state bakes, the coast is getting slammed by this massive southerly swell fueled by Tropical Storm Genevieve, bringing like 9-foot wave sets and dangerous rip currents.
It perfectly illustrates how volatile the boundaries of these systems can be. But, the most revealing interaction is happening just east of that core heat, right in the mountains of New Mexico.
Yes. I am so glad you brought that up because I have a major question about this for you.
Sure.
The sources state that amidst this historic heat in the desert Southwest, active monsoon moisture is hitting the mountains in New Mexico and causing catastrophic flash floods. Now wait, if I'm looking at this logically, shouldn't 115-degree heat dry the ground out so completely that when the rain finally falls, the dirt just absorbs it instantly, like a super dry sponge?
You'd think so, right? It is completely counterintuitive, but the exact opposite happens.
Really?
Yeah. When soil is subjected to extreme, prolonged heat, it undergoes a biological and physical change. The organic matter inside the dirt essentially cooks. It releases these waxy residues that coat the soil particles.
Waxy residues.
Yeah, and this creates a condition known as hydrophobic soil. So the ground stops acting like a sponge, and it actually starts acting like a sheet of concrete. It physically repels the water.
Oh, wow. So the water literally just bounces off the dirt.
Exactly. It hits the ground and immediately sheets sideways. So when you force rich monsoon moisture up the side of a mountain, the air cools, condenses, and drops an enormous volume of water very quickly.
And it has nowhere to go.
Right. That water hits the waxy, baked earth and has absolutely nowhere to go but down. It gathers speed, funneling into canyons, and that is how you end up with 115 degrees in the valley and a raging flash flood tearing down the mountain a few miles away at the exact same moment.
That is insane. Okay, so we have this massive wall of baked, pressurized thermal energy out west, but, the atmosphere never sits still.
Never.
That thermal energy is constantly trying to balance itself, which means this massive high-pressure system inevitably pushes east. And when an unstoppable force of dry heat slams into a wall of rich moisture, the atmosphere gets incredibly violent.
Yeah, we are moving into the collision zone now. This is where the dry, stable heat of the west crashes into the unstable, moisture-rich air of the east. And the trigger for this violence is a very specific atmospheric mechanism.
Right, because we see a minor version of this collision in Texas, where a weak cold front is dropping Dallas down from 104 degrees to the upper 90s, which I guess is relief.
Relatively speaking, sure.
Yeah, and the air down there is just hazy with that Oregon smoke we talked about.
Yeah.
But the real explosion is happening further north and east.
Yes, it is.
The sources highlight a squall line moving through Chicago that is reorganizing because a, quote, mid-level trough is amplifying over the lower Ohio Valley.
Right.
Now, I need you to break down a mid-level trough for me visually because that just sounds like pure meteorology jargon.
It definitely is jargon. Let's visualize it physically. Imagine the atmosphere over the Midwest as a tightly stretched mattress.
Oh, I got it.
A trough occurs when a mass of colder, heavier air dips down from the north and presses into that mattress. It carves out a deep valley or a trough of lower atmospheric pressure.
Ah, I see.
And nature abhors a vacuum. So as that deep valley of low pressure amplifies over the tri-state area there, Illinois, Indiana, Kentucky, it physically acts like a vacuum cleaner. It aggressively sucks in air masses from the surrounding regions to fill the void.
Oh, man, here's where it gets really interesting because it is pulling in two completely incompatible types of air.
Very incompatible.
It's like tossing a cold water balloon onto a scorching hot griddle, right? It is pulling down that heavy, cooler air from the north and simultaneously sucking up this deep reservoir of humid, saturated air straight from the Gulf of Mexico.
If we connect this to the bigger picture, your griddle analogy is exactly how severe convection works.
Oh, really?
Yeah. When that heavy, dense, cold air meets the lighter, hot, moist air from the Gulf, the cold air wedges underneath it like a snowplow.
Okay.
And it forces all that hot, saturated air violently upward into the atmosphere at incredible speeds.
And as that hot air shoots upward, it hits the freezing upper atmosphere, condenses instantly, and all that latent heat energy is suddenly converted into terrifying kinetic energy.
Precisely. That is the physical mechanism of severe convection. It takes standard summer heat and transforms it into massive rotating thunderstorms.
The kind that drop large hail and produce straight-line winds.
Exactly. Winds that can literally tear the roofs off houses. That is why this specific collision is threatening a massive corridor of the country.
Right, the Storm Prediction Center is tracking severe storm risks from Cleveland and Cincinnati in the Midwest, all the way down through Nashville, Birmingham, and Mobile in the Deep South.
It is a massive front of violence.
It really is. And the areas just ahead of that front are trapped. Like Jackson, Mississippi is enduring severe heat stress with overnight lows stuck above 79 degrees. Louisiana is just sitting in the bullseye of tropical moisture with zero relief.
Yeah.
But all that violent kinetic energy, all those severe storms churning through the Ohio Valley and the South, they are marching steadily toward the Atlantic coast.
And this brings us to the final and perhaps most precarious piece of the puzzle here.
That's right.
Because these storm systems are highly dangerous on their own, obviously, but they are not hitting dry land. They are colliding with an East Coast landscape that is fundamentally compromised.
Compromised how?
Yeah.
Because the report paints a very clear picture of a waterlogged eastern seaboard. Let's look at Florida. They are locked in this oppressive pattern, right? Steamy mornings, a heat index pushing 107 degrees in Jacksonville, and then daily afternoon thunderstorms.
Yeah.
But the sources emphasize that the real danger isn't the storms themselves. It is the ground they are falling on.
Yeah, to understand the danger in Florida and really up the entire East Coast, we have to look at antecedent conditions.
Meaning what happened before.
Right. This means the weather that happened last week dictates your baseline risk for today. The soils across Florida's Big Bend and up through the mid-Atlantic are already heavily saturated from the remnants of post-tropical storm Bertha.
Okay, so let's visualize the soil like a giant bucket. Normally, the Florida soil can handle a typical afternoon thunderstorm, right?
Normally, yes.
The rain falls, the bucket fills halfway, and over the next few days, it slowly drains into the aquifer.
But because of Bertha, that bucket is still filled to the absolute brim. The water table is sitting literally inches below the surface.
Oh, wow.
So when today's totally normal, standard issue sea breeze thunderstorm arrives, it doesn't take 5 inches of rain to cause a flood. It takes half an inch.
Just half an inch.
Because the soil has zero capacity left. So the water immediately sheets across the surface, flooding streets and overwhelming drainage systems instantly.
So what does this all mean for you, the listener? Like, if you live in Florida or North Carolina, how does rain from an old storm named Bertha make today's normal afternoon thunderstorm suddenly a flash flood emergency?
Well, this raises an important question about that sponge effect we talked about. Previous extreme weather events physically lower the threshold for disaster.
So a minor storm today is a catastrophe because of a storm that passed a week ago.
Exactly. And we see this lowered threshold causing panic all the way up the coast right now. The mid-Atlantic is bracing for flash flooding from Baltimore down through Richmond and Raleigh.
Yeah, the sources specifically highlight the North Carolina Piedmont, where coastal areas already absorbed 5+ inches of rain from Bertha earlier this week. The streams there are already running at bank full.
Any additional moisture from this advancing front will trigger immediate rapid runoff.
And the flood watches extend all the way through New York, Connecticut, and western Massachusetts, too.
Right. The collision of air masses brought their temperatures down into the upper 70s, low 80s, but they're staring down the barrel of localized rainfall totals of 1 to 3 inches.
And the humidity is rushing right back in.
Definitely. And the real threat in the Northeast is the isolated pockets where these storms might stall, dumping up to 4 or 5 inches in a single afternoon.
Wait, what actually causes a storm to stall like that? We hear about it often, but why wouldn't a storm just keep moving?
Well, storms are steered by upper-level winds. That's the same jet stream that is carrying the smoke from Oregon.
Right, the conveyor belt.
Exactly. But in the summer, the jet stream often retreats far to the north into Canada, which leaves the atmospheric steering currents very weak over the Northeast.
So nothing is pushing them along.
Exactly. Without those strong winds to push the system, the storm just parks over one spot. It acts like an open fire hose pointed at a single neighborhood.
Oh, man.
And when you point a fire hose at ground that is already completely saturated from previous storms, you get devastating urban and river flooding.
It is truly breathtaking to just step back and trace this entire continental engine. I mean, we started our journey in the Pacific Northwest, decoding how single-digit humidity and 30-mile-per-hour winds allowed a spark to consume 1.7 million acres.
Yeah, straining our national firefighting logistics to the breaking point.
Exactly, and injecting a massive plume of smoke directly into the jet stream.
And then we observed how the thermodynamics of a high-pressure heat dome acted as a lid over the West, trapping thermal energy to the point where urban infrastructure in Phoenix couldn't even cool off at night.
Right. And baking the mountain soils in New Mexico so thoroughly that they became chemically hydrophobic, turning monsoon rains into lethal flash floods.
We tracked that massive wall of pressurized heat as it pushed east, carving a trough into the atmosphere over the Ohio Valley, violently sucking up Gulf moisture and converting latent heat into severe, damaging storms across the Midwest and the Deep South.
And finally, we watched that kinetic energy cascade onto the East Coast, where soils already saturated by previous tropical systems had absolutely zero capacity left,
turning ordinary afternoon showers into instant flash flood emergencies.
It fundamentally destroys the illusion of local weather. Being well-informed means understanding that the heavy rain flooding the street outside your window in New York, well, it might be driven by the mechanics of a heat wave 2 time zones away.
It really is all connected through the transfer of energy.
Yeah, incredible.
And, I think this leaves us with something we all need to deeply consider.
What's that?
If a storm that dissipated a week ago leaves the soil saturated and sets the stage for a flood today, and a single fire season in Oregon can blanket half a continent in hazardous smoke, how must we rethink our entire concept of disaster preparedness?
That's a great point.
Are we too hyper-focused on preparing only for threats that originate in our own zip codes, when the physics of our atmosphere dictate that the dominoes leading to our local disaster might start falling thousands of miles away?
That is a brilliant and really sobering point to leave you with. If you only look at the isolated sun and cloud icons on your phone, you miss the giant atmospheric engine running in the background. Your local risk is intimately tied to a continental system.
Absolutely.
Well, thank you so much for joining us for this deep dive.
Yeah.
Stay curious, keep looking at the bigger picture, and we will catch you next time as we continue to connect the dots.